Did you know that right now there are nearly 1 million pieces of junk orbiting Earth, each bigger than a baseball, and they're moving at speeds up to 17,000 miles per hour? This isn't just litter. It's a high-speed minefield in space, and it's getting more crowded every day. What exactly is this space junk? It's a mix of everything from old, dead satellites and spent rocket stages to tiny fragments from collisions and even tools dropped by astronauts. Think of it as a cosmic ghost town of our spacefaring history, and it's a ghost town that's starting to cause some serious problems. Why should we care about a bunch of trash floating thousands of miles above our heads? Well, for starters, what goes up sometimes comes down. While most small pieces burn up harmlessly in the atmosphere, larger objects can and do survive re-entry. We've been lucky so far that they've landed in oceans or unpopulated areas. But as the amount of debris grows, so does the risk of a piece causing real damage on the ground. But the more immediate threat is to our active space infrastructure. We rely on satellites for everything: GPS navigation, weather forecasting, global communication, even your credit card transactions. Each of these vital satellites is a sitting duck. A collision with even a small piece of debris can be catastrophic, disabling or completely destroying a multi-million-dollar satellite. This chain reaction, known as the Kessler syndrome, is a nightmare scenario where one collision creates more debris, leading to more collisions until low Earth orbit becomes completely unusable. And what about the future of space exploration? Imagine planning a trip to Mars or even just a sightseeing tour into orbit. With the current amount of junk, every launch is like playing Russian roulette. The International Space Station already has to perform regular evasive maneuvers to dodge debris if we want to make space travel safer and more routine. For astronauts and future space tourists alike, we have to clean up our cosmic backyard. So, how do we tackle this enormous challenge? Many ideas have been proposed over the years, from giant nets and harpoons to robotic arms that grab and orbit junk. But now, Japan is pioneering a fascinating and futuristic solution that sounds like something straight out of science fiction. Researchers at the Japan Aerospace Exploration Agency, or JAXA, are developing a system that uses lasers. No, they're not trying to blast the debris to smithereens. That would just create more, smaller pieces. Instead, the idea is incredibly clever. They plan to aim a powerful laser at a piece of debris from a satellite or a ground station. The intense energy from the laser beam will vaporize a tiny part of the debris surface. This process creates a small puff of gas, which acts like a microthruster, gently pushing the object. By precisely controlling these laser pulses, they can nudge the debris into a new trajectory. The goal is to slightly slow it down, causing its orbit to decay. This will guide the piece of junk into a controlled re-entry into Earth's atmosphere, where it will safely and completely burn up over an ocean. It's a clean, elegant, and contact-free method of taking out the trash. This laser-based approach is one of the most advanced and promising solutions we have. It could be a game changer, allowing us to systematically clear the orbital highways for the next generation of satellites and spacecraft. The challenge is immense, but the ingenuity of scientists and engineers gives us hope. Cleaning up space is no longer just a good idea. It's an absolute necessity. It's about protecting our vital technology, ensuring the safety of future explorers, and being responsible stewards of the final frontier. The sky above isn't infinite storage space. It's a precious resource we need to preserve. What do you think about this laser cleanup plan? Let us know in the comments below. And if you found this fascinating, don't forget to like this video and subscribe for more deep dives into the future of science and technology. Thanks for watching.